Hello and welcome to lab number 10. The title of this lab is a simple periscope. In this lab, we are going to apply a previously acquired knowledge in the labs that we already covered, specifically reflection of light, to create a simple optical system that has found a use in many different fields of science, and that optical system is known as periscope. Periscope is an optical device that consists of two mirrors that are positioned at 45 degrees parallel to each other, and as already mentioned, it's been used in many different types of applications. Specifically in marine warfare, it's used for submarine operatives that are submerged into the water to observe the enemy activity above the water. Historically, it has been extensively used to observe the enemy activity above the trenches during the World War I, where it saved many lives. So in this lab, we are going to use the law of reflection that we previously covered to theoretically analyze a simple problem and provide a practical solution using a few mirrors and a red laser pointer. The equipment that we are going to use in this lab is as follows: a red laser diode module, two mirrors mounted on two wooden blocks, a protractor, a pencil, and a white sheet of paper. Here's the sketch of a problem that we are trying to solve in this lab. So it's a marine problem. Here on the top surface of the ocean or sea, we have an enemy boat. And we are positioned here in this submarine. And now that we are under the surface, we cannot see this boat, and the question is how we can create an optical system that is going to enable us to see this enemy boat even though we are under the water. So this is a simple problem of a manipulation of the light. The way how we are going to do it, we are going to create a light ray originating from the enemy boat, and then we have to manipulate that light ray in a way that it's being received in this submarine. So the first light ray that we are going to construct is the light ray that propagates parallel to the surface of the ocean. And then we want to manipulate this light ray that is propagating parallel to the surface of the ocean so that it bends in a vertical direction. And then again at this point here in front of our submarine, we want to manipulate the light by bending it in the direction of the submarine. Okay, so here's an approved sketch of our practical optical problem. As you can see here, we have a light ray that propagates along the straight line parallel to the surface of the ocean. And then at this point here, the light is changing direction. It's moving downwards in a vertical direction. And again here at this point, it's gonna change direction. It's gonna move in a horizontal direction. So as long as the light propagates along the straight line, that light is not manipulated. And obviously you can immediately observe that there's going to be 2 points where we manipulated the light. That's going to be this point here where the light changes directions from horizontal to the left towards the submarine in a vertical direction. And then again there's also this point here where we manipulated light by changing its direction from the vertical direction back to the horizontal to the left. So the question is how we can construct an optical system, how we can create an optical system that is going to be manipulating the light at this point here and then at the point directly in front of the submarine. Obviously, this is a problem of a periscope, and manipulation of the light here is in a sense of changing its direction. There's two optical phenomena that we already covered in this series of optical experiments that are associated with the change of the direction of the light propagation. Those two phenomena would be light reflection and the light refraction or bending of the light. So in specific case, we are going to use the light reflection to create a simple periscope that is going to enable us to manipulate the light at the 2 points of interest so that we can see this enemy boat on the surface of the ocean even though we are in the submarine. Okay, now that we decided to use a reflection of light, obviously the optical component that is going to be used to produce the reflection is going to be the mirror. The question is how we are going to position the mirror at this point here so that it creates the reflection by changing the direction of the light from the horizontal to the vertical. You can see here that this angle between the incident light ray and potentially reflected light ray is equal to 90 degrees. So this angle here is equal to 90 degrees. And this angle of 90 degrees is equal to the sum of the incident and reflected angle. So we have to split this angle here in two angles, incident angle and reflected angle, so that their total is equal to 90 degrees. We also know from the law of refraction that the incident angle is equal to the reflected angle. And we also know that the sum of these two angles is equal to 90 degrees, as we just elaborated. So if you solve this equation of two unknowns, you're going to realize that these two angles are supposed to be equal to 45 degrees. So we have to split this angle in two equal angles of 45 degrees. So the total sum is going to be 90 degrees. So how are we going to split this angle? You can use the protractor. So we are going to position the protractor right along the horizontal direction, and then we are going to measure 45 degrees right there. And then we can establish this line here. This line here is so-called normal, and now this is going to be our incident angle, theta incident, which in this case is going to be equal to 45 degrees. And then this angle here is going to be equal to the reflected angle. So this is theta reflected. That's also equal to 45 degrees. So the law of reflection applies in this case, and we have established the reflection by which we are going to manipulate the light to move from a horizontal direction into the vertical direction. Now, we also know that this is our reference line or reference normal that's perpendicular to the surface of the mirror. So we want to position the mirror so that the surface of the mirror is perpendicular to this reference line. So what I'm going to do now is I'm going to position the reference line along my protractor, along the reference line in the case of our reflection, and I'm going to measure 90 degrees over on this side, and then I'm going to draw this straight line. The line that I just constructed is going to be the line along which we have to position the surface of our first mirror. Now you're going to repeat the same reasoning on the second point of light manipulation, which is this point all the way down here, where we would want to position the mirror so that the mirror reflects this light ray in this horizontal direction into the submarine. Okay, so here's the final sketch of our optical system. So you can see that here at the second point of light manipulation, we also use the similar reasoning as on the first point of manipulation of light, where we establish the incident angle and the reflected angle reference axis. We split this angle here into two equal angles of 45 degrees, and then establish the reference axis, and then finally the surface of the mirror that is perpendicular to the reference axis. As you can see here, we have created a simple optical system that consists of two mirrors, one here on the top surface and one here in front of the submarine. And that simple optical system again consists of two mirrors that are going to manipulate the light so that the light that propagates off of the enemy boat is going to be turned here in a vertical direction, and then again here in a horizontal direction, and ultimately it's going to come into our optical system here, where we are observing what is happening on the surface, above the surface of the ocean. So in order to confirm all this reasoning behind the theory that's been outlined on the sketch, we are going to use the laser. So we are going to shoot the laser off of the enemy boat, and then we are going to put two actual mirrors here, and we're expecting to see the laser beam entering here the submarine. So the laser beam that we're going to position here at the enemy boat is going to represent the picture or the light coming off of the enemy boat, and then we want to receive that picture through this optical system into the submarine. Here we position our laser pointer, we taped it down to the workbench, and you can see that the laser pointer is shooting the beam along this first red line, or our first light ray. We can simply check that by using the pencil. So if I take the pencil, we can see that this laser beam is hitting the pencil along our red line. Now, the first thing that we want to do is we want to manipulate this beam. As you can see right now, the beam continues propagating along the straight line. So at this point here, we want to manipulate the light beam to turn it in a vertical direction. So we're going to take one of our mirrors and position it along the line that we established as our mirror surface. As you can see now, laser beam is moving along the red line in a vertical direction. We are still not seeing anything in our submarine, so we need the second mirror to put right there. And as you can see right now, the light ray off of our laser beam is hitting the first mirror, being reflected in a vertical direction, and then hits the second mirror, and again is being reflected in horizontal direction. And right now you can see a lot of red light in the submarine, meaning everything what is coming out of this enemy boat is basically entering this submarine. So the picture of the enemy boat has been basically transferred through this system of two mirrors. So we created an optical system that's called periscope, that consists consists of two mirrors that are manipulating the light beam to enter the submarine so that we can observe what is going on above the surface of the ocean, although we are in a submarine that's underneath. So the clear proof of this optical system operation is this huge red light that you're seeing here in the back screen that's in the direction of our submarine. But you can also see that this red light is very spread out, meaning the light has been diverged significantly as it propagating along this line. So you may give some thought as to how you could make this light more focused, what type of optical component you can use here in the submarine to take this blurry divergent red spot and turn it into something that's more focused.